All right, what's going on? Coach Daab here with Daab Labs. Today we are talking, this is our first video for algebraic manipulation remediation. This is a foundational skill in physics, so we got to make sure we can do this, right? So start with some basic stuff and we'll have some sillier examples here in a second, right? But just for the foundational stuff, always make sure you can do this. Now, I expect that a good chunk of you, this should not be difficult, right? That's okay. But we do want to practice, just make sure you can do these things, right? So hopefully I'm not having to spend much time on this first section. The only thing I'll remind you is that when we want to take something that's been added, right, to one side, then we need to subtract from both sides, right? And so then that would give us our x equals 5, right? All right, so hopefully that one is easy for you guys, okay? Same thing here for our second one. Once again, just kind of addressing this premise of, look, right, first we've got this plus 5. We want to get that, we're trying to isolate the v. So we want to get that plus 5 gone. And so remember, we just add plus 5 to both sides. And then we're end up with our 3v equals, plus 0 equals 15, right? And then another core principle, remember, whenever we have a coefficient here, 3v, 3 times v, you're essentially multiplying by the reciprocal or dividing, okay? So we want to get this 3 over to the other side so that v is by itself. Since 3 is multiplied, right, 3 times v is currently what's happening, we need to do the opposite, right? So I'm going to divide by 3 on both sides, all right? So that's why we'll do this. And so then we're able to find out that our v, right, would be equal to 5. All right, so first one was, hey, we can subtract from both sides to get rid of that addition. Second one was 2 steps. We added 5 to both sides, and then we're able to divide our 3 out in order to solve for v. All right, so we get a little bit harder, but not too much. This is and then number 3 is an example of the same variable being on both sides of the equation, right? And once again, there's loads of ways. I fully expect that some of y'all could do this in your head, right? But once again, this is just practice. The equations get harder. There gets to be more variables. So we do want to just practice the process as silly as it sounds, right? So the first thing I would probably do, I'm not a huge fan of negatives, so I usually try to get rid of them if I can. You do not have to do it this way, obviously, but I would probably add 6 to both sides first, right? And so then I would end up with my 2t plus 9 equals 5t. All right, so what we did was got rid of one of those whole numbers, right? We got rid of the minus 6 by adding 6 to each side. And now what we want to do is get rid of that 9, which, here I am trying to avoid the negatives, and I'm going to have to make this negative anyways, right? So one thing, I guess technically I don't have to. There's a couple different ways we could approach this. Once again, I expect this to be pretty simple for most of y'all, but I like to just go ahead and isolate the variable if I can. So I would then, remember here, we're not going to divide by 2 to get the t over there because it's 2t plus 9, right? If we divide it by 2, then we'd also have to divide 9 by 2 and it would get all nasty, right? So remember that what this means is that this whole thing is together as one piece. Ooh, let's do a different color, right? And so we want to treat this kind of like we did with the whole numbers in order to move it over to the other side. So I'm going to minus 2t to this side and minus 2t to this side, right? That's going to get rid of that t. It's going to subtract 2t from my 5t, but then you can see that all I will have left is my 3t equals 9, right? And then lastly, in order to get that 3 over, we could multiply by 1/3 or divide by 3. And so t would be equal to 9, or excuse me, 3, right? Okay. And I don't have any units yet. I know that you guys could make assumptions for what these units should be, but for now it's just algebraic practice. So don't worry too much about the units. We will get there, okay? Number 4, a little bit difficult, more difficult, but still not too bad. We're just trying to solve for r. There's an exponent now, right? We've got to consider, but everything else would be the same, right? So first thing we want to do is get this pi, right? Get rid of this pi and get it over to the other side. So I'm going to Sorry, I had weird noise going off down here. So I'm going to go ahead and divide both sides by pi, right? Divide this side by pi, divide this side by pi, so that we end up with a over pi equals r squared. Okay. Now, this is a little tricky for some people, right? But essentially now we're trying to isolate r. Some people would be okay with us saying that this is r, but this isn't simplified, right? Because r squared is the same thing as saying r times r, and we just want one r in order to have this simplified expression, right? So remember, we're going to do the opposite to whatever it is in order to get something to move over to the other side. So we can see here that I have a r squared, right? And so if it's squared, then in order to get it over to the other side, I need to square a root, right? But unfortunately, that means I'm going to be having to square root both sides of the equation, right? And unfortunately, when we end up with this r, oh, not capital R, sorry, lowercase r, we're going to end up with this, right, root a over root pi, or just root a over pi, all right? And it's not super pretty, but this is simplified, and this is our best answer here, right? And so we just want to isolate r, so we divide it over the pi first, and then we take the square root, and so therefore our r should be equal to the root of a over pi, or the area over pi, okay? Well, we're getting there. All right, so this next one is a super, I'm going to go ahead and tell you the super famous equation, just because you're going to see it a million times if you haven't already. But this is what we like to call third kinematics equation, or one of the equations of motion, okay? And here, notice that they've got this little v0. This, for some of you, this might be the first time you've seen this. I hope not, but it could be. And so just know, don't get freaked out in physics by the subscripts, okay? You're going to have all sorts of subscripts. You could have T1, you could have T2, you could have T3, right? It doesn't matter. All that this is corresponds to is that there's multiple versions. If I have T1 and T2, that means that I have two different time values that are different from one another that I want to use in my equation, right? V naught is what this little zero looking thing is called, right? It just means initial or beginning. Think of like computer science zero, right? But V naught, you might see written elsewhere as VI for V initial, right? They mean the same thing. If you're using the convention with VI though, right, more than likely it just ends in V for V final, whereas with our V naught a lot of times you could see V final or just V. Point being, V naught, the main thing, I don't want to confuse you guys, V naught or V sub O means the beginning, right? T sub naught would be the beginning time. A sub naught would be the accelerating at the beginning, right? So anytime you see this little naught or zero kind of symbol as a subscript, it's just saying it's the beginning, right? So what they want us to do here is find the initial velocity. They want me to isolate initial velocity. Okay, and this is going to get a little bit trickier because you can see what kind of equation this is from a math people. This is a quadratic equation, right? But the first thing I'm going to do is let's just go ahead and see what happens if we try to do this, right? So I'm just going to go ahead and add 1/2 at squared, or excuse me, subtract 1/2 at squared from each side. All right, and so then I would end up with delta x minus 1/2 at squared equals v initial t, right? And so now all we have to do, right, we need to isolate v, or v naught, excuse me. So we need to divide both sides by t. However, notice this where you got to pay attention, okay? Because since this whole left side of the expression, right, like this, and only one side, right, this side has a t, the delta x side doesn't have a t, then when I divide both sides by t, I have to be careful because it's not just going to eliminate that t in minus 1/2 at squared, but it's also going to add another one under my delta x, right? And so just so we can, let me clear this up for y'all so you see what I mean. All right, so we're going to take this delta x equals t plus 1/2 at squared, right? And then we ended up with delta x minus 1/2 at squared equals the initial t, right? And so now what we're saying is we're going to divide both sides by t to isolate, right? That'll achieve me getting the initial velocity by itself, but I also am dividing this side by t. And what you want to avoid is you don't want to end up saying, okay, well, delta x minus 1/2 at, equals v naught, right? We don't want to do that because, remember, we're dividing both sides by t. We're not just dividing half of one side by t, right? And so this right here still needs to be represented, that x over t, delta x over t, which, change in distance over time. And you can imagine what that might represent. But I digress, all right? My point being that we are still left with delta x over t, right, minus 1/2 at, right? The square is gone because we got rid of one of the t's in dividing. And then we set that equal to v initial, okay? And so this is saying, hey, v initial will be equal to, let's think about it for a second. With the initial speed, does it make sense? The initial speed would be equal to whatever the total velocity of the whole trip was minus some average of this acceleration for some time. And to me, that seems pretty legit. Like that could actually work, right? And so this would be how we do that. That's more of a, I'd say this is a little bit more realistic of a problem for AP Physics. We're getting a little bit more close to like what you would actually be doing. But once again, you can't dream of doing something like this, right? You can't dream of doing something like this one that we just did if you couldn't do these, right? And that's the whole point of this. And I know for a lot of y'all, those first few ones are silly, but there are people that, need a refresher. And there are some people who just need to practice a little bit more. Okay, so we've gotten all the way through, and we're to our last one here, which is my range equation, if anyone knows what that is. But essentially, they're saying that the range of an object or projectile is going to be equal to the velocity squared times sine 2 theta over g. Okay, this is what's called the ground-to-ground range equation. It does not work if we're shooting off a cliff, but ground-to-ground, it will work. Okay. They want us to find theta. This is actually not as bad as you might think, but we want to be careful with that sine 2 theta portion, right? So the first thing that we could do if we want to, right, is we can go ahead and divide or multiply over g, right? So now we have r times g equals b squared sine 2 theta. All right. And so then the next step, so we'll say that was step 1. And then let's go to step 2. Let's go ahead and get that v squared over there, right? So now we're going to end up with rg over v squared because we're able to divide both sides by v squared, right? So now I'm saying r times g over v squared will equal sine 2 theta, okay? Now, this is where it gets a little bit tricky, right? So what we don't want to do here is we don't want to try to be pushing sine or cosine in our calculator, right? What we need to understand here is, and then anytime that we have like let's say sine 41 degrees, right, equals, and it would give us some opposite over hypotenuse, right? That's our trig, which we'll talk about later, right? But so we have this sine, but let's just say that, we knew sine 41, and let's just say we know our hypotenuse, right? And we're trying to find the opposite side, right? Well, actually, this is a bad example. So what I'm actually trying to say here is because there's the 2 theta, right, and because there's a sine, we want to treat them differently. We don't want to attack them both at the same time. So what I might do is, remember, anytime you move sine over algebraically, you're going to do the inverse, right? So this would be the inverse sine of rg over v squared, right, is equal to 2 theta. Okay, and so then in theory, then we should just be able to, now we just have a 2 theta, which is just 2 times theta, which means we should be able to then divide both sides by 2 to get our final answer. Okay, so our final answer should look something like, and we won't simplify yet, let's do sine inverse r times g over v squared, right? And then we took this whole thing and divided it by 2, right? And we're saying that this is going to be equal to our theta, right? And so from here, you could simplify a little bit further, obviously distribute, but you get the idea. You just want to be very careful because what's going to happen in physics is you're going to be deriving some of these equations and you're going to get something that looks like this. And you're going to feel, especially coming from a math class where everything's perfect and either cancels out or goes to one or whatever, you're going to see something like this. And if you're not confident in your ability, you're going to be like, oh gosh, I did this wrong. And you're going to go back and you're going to work it 3 times more, getting the same answer every time. And then either one of two things is going to happen. You're going to change it at the last minute, get the answer wrong, and have wasted all the time that you could have used on other questions. Or you're going to have spent 15 minutes on that one question, and yeah, good for you. You got it right. But you also didn't finish the test because you spent all the time redoing this question. All right. So that's where this practice comes in. I know it seems silly, but that's where this matters, is understanding, hey, this is realistic. Like this can happen, and I'm not going to get bogged down thinking that this isn't legit. All right. So this is just the first algebraic manipulation video. There will be a couple more as I step up the difficulty. I just wanted to kind of go through this for those people who are needing that initial foundation. So I hope this helps you guys. Check out the next video, which will probably be about units, or it might be my second algebraic manipulation video. But until next time, I hope you learned something.